Okay, hello everyone. My name is David Romero from this house, from the University of Seville. I will present my work titled Open Science Principle in Software Product Lines, the case of the UVL ecosystem. This is our ecosystem, this is UVL, and UVL have my tool based on open science principle and our analysis tool called FlamaPy. This is our research group. This is me, it's evident. This is my thesis director. Both of them are my thesis director, David Benavides and José. This is José Miguel Horcas from the University of Malaga. And this is Megha from this University of Seville too. Well, we are going to talk about this is the roadmap we are going to follow. First of all, I talk about the variability and software product line, yet another language called UVL, then UVL and open science, then FlamaPy, and finally, and conclusion. Okay, variability and software product line. No? Software product what? Difficult to me to understand. Okay, let's talk with a example. I really like. Is there any Valencian here? No. Sorry for this crime. It's okay. I really like. I really enjoy eating the food. Okay. For example, I have the only one, the paella valenciana, or maybe paella de marisco, seafood paella, or vegetable paella, chicken paella, or maybe in my case, in particular, in my case, I cook arroz con cosas, rice with with so many things. Okay, there is the concept of mass production. As in any other industry, I am able to produce a certain number of similar products. So the problem is it doesn't allow for customization. For example, I always produce the same paella dish, producing efficiently large amount of standardized products. So derived from the last mass production, we come to a mass customization. Let's imagine we have in a restaurant, this is me, this is my girlfriend, I wish. We have a menu and we can choose the dishes, and I don't like this ingredient. I would like to order other ingredients, and okay, and you can choose the dish of paella. You can choose the ingredients. The order goes to the kitchen, and the kitchens produce, in this case, no cooking the paella dish that I want. Okay. We can make a simile between paella product line and a software product line from the 60 years, from subroutine, through the modules, to the object, to the component and framework. In the turn of this century, we no longer see the software as an individual unit of a work. Now you can customize so many parts in a high, or maybe in a medium, or maybe in a low level. You can customize our own software, or maybe based on a variability model, based on a feature model, hence the phrase producing software to meet individual customers' needs with the near mass production efficiency. Okay, well, welcome yet another language, in this case, another language called UVL. We have the following scenario, the smartwatch configurator. I would like to say I love smartwatch, but in my case, I have got a Casio, a plastic Casio, okay? So I would like to customize my smartwatch. I have several features like screen type, sport tracking, and other feature like payment, GPS location, energy management. Okay, they are core feature. Okay, screen and energy management. They are a variable feature, optional feature, or alternative feature like payment, sport tracking, and GPS. So, okay, we have the core feature, the common feature, and the variable feature you can choose. Well, this is our variability model. Thanks to this variability model, I can customize my smartwatch. This and this one have the screen and energy management, and this one have the payment. This one and doesn't have the sport, the payment, but it has the GPS. Okay, there are several proposal for modeling this variability. We are going to focus on this one, a feature model. We have the root feature, smartwatch. We have a mandatory feature, screen and energy management. And this is the legend. Oh, yes, this is the legend. You cannot select between payment feature and a standard feature, like because an exclude constraint, constraint. If you select the sport tracking, you must to select the GPS feature. How can we model this feature? There is a proposal called Modevar. Modevar is the acronym of an international workshop or languages for modeling variabilities, international workshop. The first edition was in France in 2019. The last edition was 2 months ago in Luxembourg this year. Okay, well, thanks to this Modevar initiative, we have called the UVL. UVL is the acronym of the Universal Variability Language. It's another textual language to describe our feature model. For example, I have a namespace to avoid ¿cómo lo diría? The collision of a name. I have a feature. It's similar to other language such as Python, thanks to a text tabulation. Thanks to a text tabulation, I have a feature in a block. For example, I have a mandatory feature. I have an optional feature. I have an alternative feature. I can choose a touch or a standard screen. Okay, this is the block for the feature, and this is the block from the constraint. Okay, this is a Boolean constraint. I cannot select payment and standard at the same time. Okay, this is the visual description of a feature model, and thanks to a UVL, this is a textual description of a feature model. Well, I have 3 language levels to describe any feature model. I have the Boolean level. You can see I have the which we have already seen. I have the arithmetic level. I have the type level. For example, this one I have the power representing the power is an integer variable, represent the power in watts. For example, the feature in my model presumably consume some amount of power. We still have the same feature and the same constraints, and also have the constraint of the summatory of the power is less or equal than what I can define. This model has the the three level, the Boolean level, the type level, and the integer level. Okay. So let's talk about the UVL hub and open science principle. Okay, I have an UVL language, I have so many UVL feature model, so I have so many UVL datasets, so many. Now, say, you give me a number between 1 and 1 million, so many datasets. They are important, datasets are important because it provides the evidence base, the reproducibility, the new findings, the collaboration, transparency, the education, okay? But we have three main problems. The first problem is my data set is in a private repository, okay? It's a private repository, pues I cannot access to this data. Or maybe my data set is in a public repository, but the data is lost, or maybe Coru do an incomplete transformation, or maybe the system is down. So, thanks to the open science, do you know the open science? This is the sixth open science principle. I quickly review the open access, making scientific papers free to read for everyone, the open educational research working together across discipline and border, and open data, of course, sharing research data for everyone to access and use, open source, using and sharing open software, open source software in research, open peer review, making the suspicious open peer, making public and accessible and transparent, and open methods, making sharing the research process, the methods and tools. Okay, well, our UVL language is based on these three open science principles: open educational, open data, and of course, an open source. There is a main question that is it. Can the open science provide a solution to my UVL dataset problem? Well, yes, of course. I have the Open Aire. This is an acronym from the Open Access Infrastructure from Research in Europe. It's an online platform that connects research from all over Europe. I have an Invenio, a research data management developed by the CERN in Geneva. Okay, and thanks to the Open Aire, and thanks to Invenio, I have a Zenodo. Okay, this is an open access repository. I can upload any kind of data set. And that's all. This is the solution. But any kind of data set. Another question. In Zenodo, I can load, upload, or download any kind of data set, not only UVL. So the second question is, how do I control that only UVL datasets are uploaded? Well, in research academy, this is the problem, and the solution is my idea. Okay, that's a joke. Well, this is the UVL hub, a feature model repository using UVL and open science principle. It's a paper published in Elsevier, in Springer, in Journal of System and Software. Is developed by the University of Seville, University of Malaga, and the University of Ulm from Germany. And you can access uvlhub.io. Okay, you can check it out. This is an sneak peek. I have the latest data set. I can choose wherever data set, like a shopping cart. Okay, Thanks to a Zenodo connection, I have the DOI, the document object identifier. Okay, I can explore so many datasets. I can filter via feature a number of feature. Okay, for example, thanks to the connection of UVL Hub and Zenodo, Zenodo is the permanent storage of the UVL, okay? UVL Hub in this case, in the backend. So I am this research, this important research. I have a very important data set in UVL format, so I can upload my UVL to a UVL hub. And thanks to the connection between UVL hub and Zenodo, every time I can upload, my UVL dataset. My dataset is also available in Zenodo. Okay, if there are so many research working on other specific format in their work, they cannot upload to UVL, and also you can upload to the Zenodo thanks to this filtering layer. Okay, but what happens if the system is down? Thanks to the connection to the UVL and Zenodo, I can directly download to my dataset from the Zenodo. Okay. A quickly review from an architect. I have a web application developing in Flash. I have a local storage. Thanks to this local storage, I avoid to overconsumption of a Zenodo's public REST API. Okay, thank you. And well, let's talk about these two. Thanks to UVL, I have filtering, analysis, search, business rules, domain-specific feature, and I can adapt it to other contexts. Okay, let's talk about the FlamaPy. FlamaPy is the cutting-edge Python-based tool for automated analysis of feature models using UVL and more. You can check this domain and this direction and this address, flamapy.org, is based on this open source, open science principle. You can use FlamaPy as a tool and also as a framework. As a tool allows to analyze feature model, you have multiple interface to use, REST API or maybe web or maybe directly programming with our library, or maybe you can use FlamaPy as a framework. You can adapt it to our needs, or maybe you can integrate it in your own tools. Okay. The supported format is UVL, Fama XML, or Feature Reader, or maybe Glencoe, or other formats like conjunctive normal format or JSON, CNF. And we have so many operations. The most typical operation, give me the count list, the count feature, the estimated number of configuration. Be careful because some operation may be NP hard or maybe NP complete. Okay, and you check it out in this book, written among others by my thesis director, David Benavides, AI Driving Design, Analyzing an Application in Springle in Open Access. Okay, so the conclusion, UVL as a new textile language, using UVL for model sharing, analyzing model with FlamaPy, and thanks to an open science approach, following open science principles. This is our UVL ecosystem. And that's all. Thank you very much.
During the presentation. What How have you implemented the language?
The language with Atelier. With Atelier, yes. With a parser.
Transformer in Python.
I'm not sure. What do you think? The parser is
One for Java, Python, and
yes.
Okay.
I have many, but it's not my time, I think.
More one. About the data sets, you said that there are a lot of data sets, but you couldn't store these data sets in a set. These data sets was generated by you or not?
No.
They appeared in the internet. Are in the internet. So they was
Mm.
they were in the internet.
Bueno, no. So many data sets. I can give me what? Yeah. Okay. Okay. Sorry for the spam. It's saying it's down. It's available on Zenodo thanks to the OpenScience thing. For example, in the top dataset with the most feature model, the complete explore dataset, more than 1,000 model, CDL, operating system, another resource.
Following all the trends.
This is a protocol, so you have implemented the language.
Yes.
Okay. Thank you.
From my understanding, you've designed UVL. I fail to understand if it's only the syntax, the textual syntax, or if you've also come up with a new meta model or data model that is capturing that syntax. Something standard, or is it something you also create from scratch?
Creating from the scratch. I have the meta model. No. I have got the meta model. I'm not sure. I have only developed the UVL hub and the integration of the UVL, but the UVL development, the main development, is by another person. Like it's true.
So the idea is the ecosystem. So you have the language.
Yes.
But then David developed the UVL hub, so
Yes.
repository to share those hubs. But I mean, I'm part of the project, and we developed in this Model initiative with 36 years, discussing with the community, we came up with a more or less a standard language where we have a meta model, we have the parser, we have
So many integrations.
data sets already. Yeah.
Okay, and how widespread is this meta
How
model?
widespread in which sense?
In which sense?
Community that
Yeah.
creates feature models. Is it very much?
Yeah, so it's starting to be. So actually, did you see the reference there of the publication, the second one? Still in the second round of review.
This when
Major.
UVL.
It will be published soon. But it's more or less known in the PLC community, it's very well known. But outside that, I don't know. If you didn't know about it, maybe it's not that well known.
Yes.
Clarify that I stated that you could filter out only the UVL.
Yes.
Why is that so important?
Yes, in our case, I need to filter the feature model by the number of the feature, of the count of the feature, or maybe whatever you. Yeah, so specific filtering. The concept of the UVL is the open hubs. You can create the UVL hub or the BPM hub, or maybe you can customize this product like a software product line. So this is our fantastic idea. Yeah. Yes.
This is for one. Start with Benavides.
Yes.
The community is made by the university, or there are more institutions.
Of UVL hub or UVL?
UVL.
So UVL is the language and
You will have the
repository. Both are developed by different
This.
universities. Some of them overlapping. For example, we are in the two initiative, but some are not overlapping and maintained by different universities. Similar as the language you developed, the DSL. Okay.
Sí, okay. Thank you very much.